Hello, welcome to today's lesson. We are going to be answering a very beautiful question in chemistry, and it is taken from a topic on organic chemistry. And this question is so very much interesting, so I want you to stay up to the end so that you don't miss anything from this beautiful lesson. So, without wasting our time, let's just start answering these questions. At least we get exactly what we are looking for. So the question reads as follows. Organic acids are a homologous series of compounds having the carboxylic group COOH joined to an alkyl radical. And our first question says, what is the general formula for organic acids? What is the general formula for organic acids? So, organic acids have two main general formulas, and one of them is this here. We write it as CH, and there's N down here, and then 2N here, plus 1 COOH. This is one of them. But every single time you're going to be using this general formula, remember that to every power of n, you're going to be subtracting 1 before you replace there. And then there's also another one where you just go straight to the point by just saying C, N, okay, then H2N and O2. This other one is used when you don't need to remove or subtract 1 from the value of n. And remember, the value of n here represents the number of carbon in the chain. So don't forget to consider that one very well. So you can actually choose this one here, or you can use this one here as your general formula. Alright, now the second question says, draw the structure of butanoic acid. So, butanoic acid, from the term but, it is telling us that but is representing 4. So, butanoic acid is showing us that N is equal to what? 4. Meaning, in the chain of our carboxylic acid, we must have how many carbons? 4 carbons only. We don't need to have more than that. So, what are we going to do there? We are going to use just this formula here to help us get our answer simply. So, where there's N, we're going to be putting 4. So 4 there, okay, then H, then 2, where there is N, we put what? 4, and then O2. Okay, so from there, you can now tell me that C for 2 times 4 here there is how many? Is 8 OH, mean O2 like this. So this is what is going to be our values for our elements in our compound. So how do we draw it now? So this is what you draw. The first thing to do is you just write C, the first C's, like I showed you earlier on. Okay, then you can put one O here and another O right there on the last one with H there. And then on this one, you introduce these lines, H1 here, then you do another one here. I hope it's going to be visible, right? Another H there, then connect again here, then H, another H, then finally H. So you can see that this is your structure formula for butanoic acid. Now we said that by the end of the work, you must have how many carbons here? 4. 1, 2, 3, 4 carbons, and how many? 8 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. And 2 oxygens, which is 1, 2. That is what we need to draw right there. So with that, then you can write anything. So every single time they ask you, even for more than this type of a question, you must be able to remember that you can even solve it even when you are given a different question. But at least remember that every single time you have to start by finishing the carboxyl group here, and then the rest you join them like the one I have shown you on the board. Okay, now they're telling us now on part C, which is now they are saying that the reaction between an alcohol and an organic acid is described as esterification, and this is similar to neutralization. Now, they're telling us to say ethyl ethanoate is an ester. Name 2 reagents used to prepare it. So, the ethyl ethanoate, as usual, is an ester. Now, you need to know that for us to come up with that, we must have 2 main parts of the reactants. Alright, so the name is derived from the reactants there. So the ethyl is coming from the part which is what? Which is an alcohol. And then ethanoate, or the anoate part, is coming from what? The acid part. So this is what we're going to do now. So you can also check that this is F, meaning the first one is going to be our alcohol, which is the ethanol. It starts with F. Ethanol. And the carboxylic part here is the ethanoate. Now, so we can just say ethanoic acid. So these 2 are the main reactants of what? The main reagents used in this main reaction here. Okay. So let me wrap this part so this to answer the next question here properly with me. Now, the question tells us something here. They're saying, write a balanced chemical equation for esterification. Alright? So, esterification, like we said, we are going to have 2 main things reacting, and they are going to end up producing an ester and water. So, this is what we are going to write. So, ethanol is simply written as what? This is C2H5OH, and remember it's liquid instead. And then ethanoic acid is as CH3. Okay, then you have got what? COOH, then this is also liquid. Then this is a reversible reaction, so we can write it like that. Okay, then we can say ethyl ethanoate. Of course, it's going to be a bit longer. Let me just extend this side and this way. Finish it very well here. Okay. So, ethyl ethanoate, what you do now is you break just a few things with this same thing of yours, the work you are having. So just get the very first 2 parts, this part up to here, write it as CH3, okay, COO, alright, then just get this part which is remaining, the last part here, alright, which is the C2H5. Now we said we are going to end up producing a water as the byproduct. So this is liquid as well. And then water is our byproduct. So that is it. So you check now if it is balancing. Of course, this one is already balancing. So if you want more on how to solve, I'm sure for those people who will be like, no, why are we not using aqueous for acid? Since acid we say that we are always aqueous. In our case here, we use concentrated, acid. So we only use aqueous when we dilute it with water. So in this case, we are using a concentrated one. So it is liquid at room temperature, and we're ending up producing that one and that one. And remember, sometimes they ask you for the catalyst used. So the catalyst used in the process of esterification is concentrated sulfuric acid. So if you understood, you enjoyed this lesson, let me see you in the next one. Consider subscribing and consider sharing to your friends, also that your friend of yours also gets helped with this work. Thank you very much. Let me see you in the next one. Shalom.